A pleasant day, STEM learners. This is Sir Peter, your pre-calculus teacher. So this is the second continuation of our topic for circular function, week number 2. For today's discussion, we will talk about circular functions and the unit circle. So at this end of this video lesson, you should be able to illustrate different circular functions in a unit circle and determine if the given trigonometric point is part of the unit circle. So we're done with coterminal angles. Let's talk about this topic. Are you ready? So what are circular functions? So you consider a unit circle drawn and we draw a line going to the x-axis. A right triangle will be formed. So observe the given right triangle that will be formed later. Okay, did you see it? So given that the coordinates of P of theta are x and y, then we can say that the shorter leg or the horizontal side of the triangle is x. And the longer leg, the vertical side of the triangle is our y value. And the hypotenuse is 1. So let me label them here. So this is the x value. This is the y value. And since this is a unit circle, the unit circle has a standard equation. X squared plus y squared is equal to 1. So what is the radius? It is 1 here. So notice that we could form proportions, okay, or ratios, I mean, of sides here. For example, do you still remember SOHCAHTOA? So if you want to compute the sine theta of a function and the other circular functions, we will apply SOHCAHTOA and COSACAO. What does we mean when we say SOHCAHTOA? So we have sine is equal to the opposite side over the hypotenuse. Then cosine is equal to adjacent side over the hypotenuse. Then TOA means tangent is equal to opposite side over the adjacent. For COSACAO, I know that you know this on your grade 9 mathematics. We have the cosecant theta is equal to hypotenuse over opposite side. We have the secant theta, which is the hypotenuse over the adjacent side. And we have cotangent theta, which is equal to adjacent side over the opposite side. So again, let me label them xy and observe that there is a point on the unit circle represented by xy on the Cartesian plane. We call this one as the trigonometric point. Okay, the trigonometric point is actually represented by cosine for the x value, and for the y value, it is represented by sine. How did we get that theorem? So first, we follow saw. We have sine theta is equal to opposite over hypotenuse. So look at the reference angle. The opposite side is y, right? So y. And then the hypotenuse is 1 because that is a unit circle. So y divided by 1 is y. So do you agree now that the y value is equal to the sine of the angle? Okay, so whatever is the value of the trigonometric point will give the y value will be the sine theta. For cosine theta, we have adjacent over the hypotenuse. Observe that in given right triangle, the adjacent side of the reference angle is x. So we have x, and then the hypotenuse is 1 since we are pertaining into a unit circle. So we have x here. Next, notice that the x value of the trigonometric point is also the cosine value. And of course, to get tangent theta, that will be opposite over adjacent. And that is actually the opposite side is y over x. And we know that y is what? Y is sine theta, right? And cosine x is cosine theta. So therefore, we can also conclude that the tangent function is a ratio between your sine theta and cosine theta. So let me summarize everything. So therefore, sine is y, cosine is x, and tangent is y over x, or sine over cosine. Okay? So we let theta be an angle in standard position, and remember that P of theta will be equal to P of xy, which is what we call the trigonometric point, in which it for every terminal side of the unit circle, it will represent a certain function of the angle. So here are the summary again of sine, cosine, and tangent function. And since we have the opposite function or the reciprocal, we have cosecant theta is 1 over y, the reciprocal. Secant theta, which is 1 over x, the reciprocal of cosine theta. And the reciprocal of tangent theta is x over y. Now, given a certain trigonometric point, let us determine whether each point is part of the unit circle. So let's have the first trigonometric point. Negative 1/2, the square root of 3 over 2. So our x value is negative 1/2. Our y value is y. We know that x here is our cosine value, and y here is the sine. So by using the standard equation of a unit circle, x squared plus y squared is equal to 1, simply substitute. We have negative 1/2 squared plus the square root of 3 over 2 squared. Then we square 1, the answer is 1/4. Okay, the square root of 3 over 2, the answer is 3/4. And it will be equal to 1 equals 1. Because 1/4 plus 3/4 is 1. So the answer is yes, meaning this is a trigonometric point on the unit circle. So it's a yes. Let's have the next example. Is negative 4 over 9 and negative 5 over 9 part of the unit circle? Or is it a trigonometric point of a circular function? So our x is negative 4 over 9, y is negative 5 over 9. Again, use the equation of a unit circle. So we'll have the square of 4 is 16, the square of 9 is 81. And even if you square a negative number, it will still be positive. The square of 5 is 25, and the square of 9 is 81. So we'll have 16 over 81 plus 25 over 81 is equal to 1. And we know that 41 over 81 is less than 1. So it is not equal to 1. Therefore, the point negative 4, 9, negative 5, 9 is not a trigonometric point. Let's have 1.1 and negative 0.1. Our x is 1.1, y is negative 0.1 in the unit circle. This is how it would look like. 1.1 squared plus negative 0.1 squared is equal to 1. 1.21 plus 0.01 is equal to 1. And again, it did not equate to 1. So the correct symbol to be used is greater than So this is not a trigonometric point in a unit circle. So Sir Peter has listed here all the special angles in the unit circle, starting from the 0 degree, 330 degree, 45 degree, 60 degree, and 90 degree. Remember these angles. These are the special acute angles during your grade 9 mathematics. But now, we have a higher values of angles. We have 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and 360. All of these are what we call angles in standard position, but they are also the special angles of a unit circle. Okay? Notice that every degree of an angle corresponds to a trigonometric point or function. That's why we call it a circular function, because there is a periodic repetition of values. Observe these values. Are there repetitions? This one to that one. This one to that one. There are periodic repetitions per quadrant, as you observe. So the trigonometric point just changes sign depending on which quadrant they belong. Okay? We have 4 special points here on the unit circle. We call this one as the quadrantal points. We have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. The reason for these coordinates is because we are in a unit circle. That's why everything is in one unit, depending on their positions. Of course, if the trigonometric point is located on the positive x-axis, it will be 1, 0. On the positive y-axis, it will be 0, 1. On the negative x-axis, it is negative 1, 0. And on the negative y-axis, it is 0, negative 1. So we have no questions about the quadrantal points. Quadrantal points are formed by the measures 0 regions, okay, pi over 2 regions, pi region, and 3 pi over 2 regions. These quadrantal angles have a unit of measure which is 1/2 pi, has a, what do you call that? Have intervals of every 1/2, right? So that those are the intervals. This is the family of over 2. Okay. Next, we have the family of pi over 6. Pi over 6 regions. On the first quadrant, look at the first quadrant. On the second quadrant, we have 5 pi over 6 regions. On the third quadrant, we have 7 pi over 6. Sorry. And on the fourth quadrant, we have 11 pi over 6 regions. Notice that the trigonometric point did not change. We have the square root of 3 over 2 and 1/2. Same here, same here, same here. But how are they different? Isn't it that on the first quadrant, the sign must be positive, positive? So look at the value of cosine. Cosine is the square root of 3 over 2, while sine is 1/2. So both the cosine and the sine are positive. Next. In here, the cosine value is negative the square root of 2, square root of 3 over 2, while the sine value is positive. Notice also on the third quadrant that we have a negative, negative. And in here, we have positive, negative sign. Okay, so we also follow, but values does not change. Another family is the family of pi over 4 regions. Let us obtain them. We have 3 pi over 4, 5 pi over 4, and 7 pi over 4. That is why mathematicians use the region measure, because we can easily detect the equivalence of the trigonometric points. That's why we seldom use region, the degree measure in answering. We do not use degree in trigonometry. What we use is the region, because we can easily determine their equivalence by their denominators. Did you get it? So all of them have the square root of 2 over 2 and the square root of 2 over 2. This one. Then this is positive, positive, negative, positive, negative, negative, and then positive, negative. Notice that we also have families of pi over t regions. Got this one? We have 2 pi over 3, 4 pi over t, and then 5 pi over 3. All of them have coordinates 1/2 for the cosine value and the square root of t over 2. But their signs changes as we change the location of their terminal side of the angle. So if it is 60 degrees or pi over 3, that is a positive positive. If it is 120 degrees, that is a negative positive. And if it is 4 pi over 3, it is negative negative. And 5 pi over 3 is a positive negative. Now, where did all of these values came from? Remember that in a special right triangle, for example, let's talk about a 45-45 degree triangle or an isosceles right triangle. Since the hypotenuse is a unit circle, the hypotenuse is 1. And we know that to get the legs of a 45-45 degree angle, we multiply it by the square root of 1 over the square root of 2. Okay, so that is 1 over the square root of 2. But the square root of 2 is not accepted, so we will rationalize the denominator. Rationalizing, that will be 1 times the square root of 2. So that will be the square root of 2 over the square root of 2 times the square root of 2 is 2. So that is how we obtain these values. Because for 45-45 degree, sine 45 is the square root of 2 over 2, and cosine 45 is the square root of 2 over 2. Therefore, if you will get the value of cosine 135 degrees, you may press this one in your calculator to check. Cosine 135 degrees is negative the square root of 2 over 2. While sine 135 degrees is the square root of 2 over 2. Sine. Okay? Same with this value of 5 pi over 4. If you press in the calculator the cosine of 225 degrees, you will get negative the square root of 2 over 2, because all of these are families. Now, let's talk about 30, 60, 90 right triangle. In a 30-60, so of course, opposite the shorter leg is the 30-degree angle, and opposite the longer leg is the 60-degree angle. And this is 90 degrees. And since we are pertaining to a unit circle, the hypotenuse is 1, which is also the radius of the circle. And how do we get the shorter leg, SL, the shorter leg? To get the shorter leg is 1/2 of the hypotenuse, right? And to get the longer leg, LL, we simply multiply it by the square root of 3. So that will become 1/2 times the square root of 3 is the square root of 3 over 2. So this is how we get this angle, this one. So for a sine 30 degrees, opposite over hypotenuse. So we have 1/2 divided by 1. So the answer is 1/2. Okay, and then for a cosine 30 degrees, that is adjacent over the hypotenuse. So that is the square root of 3 over 2. So this is how we get this trigonometric point. So as you go through its family, which is 5 over 6, the same thing. When you press in the calculator 150 degrees, so get cosine, that will be the first point. Remember, the first point is xy. Okay, and x is cosine and y is sine. Do not forget that. So the trigonometric point helps us determine the value of the sine and the cosine right away, especially for the special angles. So let's have an exercise. For example, so if you memorize this unit circle, you will have no problems about the special angle. And even without the aid of the scientific calculator, you could be able to easily get functions, the circular functions of special angles. For example, you wanted to know the value of sine 120 degrees. So simply look with 120 degrees, and then it's equivalent to 2 pi over 3 radians, family of pi over 3, and get the y value. So therefore, without the aid of the calculator, we know that the value of sine 120 degrees is square root of 3 over 2. Now, what if you were given cosine 750 degrees? This is how the coterminal angles work. Because again, when we pertain to a unit circle, this is 361 complete revolution. And then 720 is a second complete revolution. And there is a remaining 30-degree angle. So therefore, the terminal angle of 750 is 30 degrees. So since we are pertaining to cosine, we will get the x value of the trigonometric point. So without using the calculator, we can easily get the cosine of an angle even if it exceeds 360 degrees. So we have related our coterminal angles with this lesson. Now, sir, how do we get the tangent function? For example, you wanted to know tangent 225 degrees. Isn't it that tangent function is y divided by x, or it is cosine theta over sine theta? So simply get the y value and the x value of the given angle. So this one, we encircle this one. So that will be negative the square root of 2 over 2 divided by negative the square root of 2 over 2, and that will be equal to 1. You may double check using your calculator. The value of tangent 225 degrees is exactly 1. So That is how mathematicians were able to use the unit circle and radian measures to describe the periodic rotations of the values. So the sine, the cosine, and the tangent functions that we know during our grade 9 mathematics only revolves within this acute angle 0, 30, 45, 60, and 90. It's only between 0 and 90. But we did not realize that there are also other angles existing, no? that in which the calculator can also compute. And with the aid of these radian measures, we were able to relate how the changes of sine happens from one quadrant to one quadrant. Remember that E of theta, reference angle, every rotation of theta is represented by a P of a trigonometric point x, y. And these x and y values gives us the sine function and the cosine function respectively. Of course, it will also involve the tangent function because we simply divide y and with x. So that will be the end of my discussion for the circular functions and the unit circle. So here are the references used in this presentation. Did you learn something? So for our next video lesson, we will talk about locating circular functions on the Cartesian plane.